Hello and welcome to the second part of the Introduction to R and Statistics for Rookies. In case you're interested, the Data Science Virtual Chapter is giving you $150 off registration. If you're interested, please contact me on jenstirrup@sequelpass.org. There's no doubt a virtual chapter to interest you. They're all free and we offer lots and lots of hours of free training throughout the year. If you're interested in data science, you might also be interested in the business intelligence and the business analytics virtual chapters as well, and we also have one dedicated to Excel. If you're interested in volunteering, please do get in touch. We have lots of opportunities for people to connect, learn and share. And our details are sequelpass.org. The hashtag on Twitter is sequelpass, and obviously sequelpass on Twitter as well. So in this session we will look at an introduction to statistics in R for rookies. Now we are going to look at the most important statistics for business. These are the statistics which we get asked for most often, and we will look at how we implement these in R. Once the session is uploaded, you'll find the notes at jenstirrup.com and also on our website at datascience.sequelpass.org. Now, statistical analysis is used widely in businesses across the world. You may use this every day and not realise it. So, for example, marketing campaigns will use statistics in order to determine how customers are classified, the spending patterns, for example. Management consultants use statistics to try and evaluate the most efficient use of resources. Website design and testing will use statistics to try and work out what is the most effective design to make people engage with the website in question. So some of the most interesting things we are looking at is where is the centre of the data if we were to plot it, and also if we were to spread the data, how would that actually look? So we have the mean. The mean is simply the average. So we take the total, we add up all the points, and then we divide it by the number of points. The median splits the data in two halves. And the mode is the most popular value, and we see the mode happening in nominal data as well. And what that means is, if you ask everyone what's their most favourite fizzy drink or something like that, everyone will give you an answer, and all you do is count up and find out which one is the most popular one. The mean is particularly sensitive to outliers, and the median is better in this case. So if you have data which has some strange outliers, it's worth taking all of these measures, and in any case it's quite interesting to understand how the mean and the median are different from one another. We are also interested in other measures of dispersion. So we have the variance, which is the average squared difference between the data points and the mean. Now the variance is actually expressed as a square, and that doesn't make sense to a lot of people. So what we talk about instead is a standard deviation, which is the square root of the variance, and it's more intuitive. So say for example you wanted to find out what was the standard deviation of dollars and how they spread out in the data set. If the dollars were expressed as a variance, that would be the square of the dollars, and we don't tend to think like that. However, using the square root means we can bring everything back to talking simply about dollars again, and people find that much more intuitive. We also look at percentiles as well. The data set is divided into 100 equal parts. And that may be interesting where you might need to know at what point do I reach 80% of my total. And then you might look there for the 80th percentile. The quartiles are the data set divided into 4 equal parts. So they're obviously divided into 25%, 50% and 75%. The interquartile range is simply the middle 50% of the data points. So in this case we would take the middle band of data where it starts at the 25% and where it ends back up at the 75% mark, and that would simply give us the interquartile range. The reason we look at that is we are trying to understand what is most interesting about the data outside of that range. So in this case, we're trying to work out the spread of the data relative to the centre. Are the data points close together or are they spread out? We also have measures of association. Covariance are how variables vary together, rise together and fall together. An example of covariance might simply be height and weight. How does someone's height vary with their weight, for example? And we look at correlations as well, how data points are similar to one another. And this is identified between being a -1 or simply 1 on its own. So when we look at statistics in business, what we are trying to do is we are trying to measure uncertainty. And that's really what probability is doing. So in probability, we talk about likelihoods. We don't actually talk about outcomes that are definitively black and white and very, very simple. It tends to be about the likelihood that something will happen. Now, probability is based on sets, and we use sets in SQL. So if you're familiar with SQL Server and writing queries, you're already pushing data around in sets. We determine the probability of the outcomes. So in this case, all possible outcomes are known in advance, but the actual outcome is not known. So that's what we mean when we start to talk about probabilities. A set is just simply a collection of objects. And what we do is we apply maths to the set. We apply the union, intersection, or the complement. The union is simply all members of both sets. Intersection is only the members in both sets. The complement is what is not in the set. So then we apply rules in order to find out more about the certainty of the data. So we might have the addition rule, which is the probability of the union of two sets. The multiplication rule is the probability of the intersection, and the complement rule is the probability of not being an element in the resulting set. We also have different types of distributions. Now this really means how differently do we look at the data when we're looking at probability. So binomial distribution is simply one of two outcomes. You'll probably see examples of heads or tails, and that's very simple. Heads or tails, one or two outcomes. The geometric distribution is the probability before success results. In that case, say for example, you want to be looking at the point at which 80% of registrations are effective. You want to know which point have you actually reached 80% of effective registrations. So the Poisson distribution is the probability that a number of events will occur within a given time frame. The uniform distribution is where all of the variables are evenly distributed, and we tend to see that like a flat line. But the most interesting thing when we look at statistics in business is the normal distribution or the bell-shaped curve. That helps you to determine what statistical tests should you use. So if you use data which is quite close to the bell-shaped curve, then that means you're much more likely to be able to use stronger and more robust statistical tests than you would do if the data was scattered, not very well put together in terms of the definition, and in that case you tend to use less robust statistical rules in order to evaluate the data. So what tools do we have in R in order to accomplish this? Well, in R, 80% of your time will be spent preparing and wrangling data, and the remainder of your time will be spent complaining about it. So the essential R data manipulation tool set is called dplyr. In data wrangling, what are the main tasks? Filtering rows, selecting columns of data, adding new variables, sorting and aggregating. These are 5 key data manipulation tasks which we do in R. Now if you bear with me, what I'm going to do is bring up RStudio now. So let's bring up RStudio. Now I will post these code pieces to my site at jenstirrup.com. Now the first thing we want to do is install some packages, so I'm going to do that. Now it's asked if I can be restarted prior to reinstalling. I'm going to say no, because I've already installed these already. So R, as we can see from the console output down the bottom, has gone off and it's finding all of the packages that we need. So what I want to do now is call those libraries. So I'm going to highlight them in my code file, I'm going to press the run button, and there are some warning messages about the versions of R, but the main thing is that we are calling the libraries that we need in order to do some visualization. In this very short sequence, all I'm going to do is show you how to use some very basic R in order to do some very simple descriptive statistics, and we'll look at visualizing the data towards the end. So what I've just done there is we have a data set called diamonds. It's one of the default data sets that it comes with R. So if we want to see what's in the data set, what we want to do is view it. So here we've got the caret, the cut, color, clarity, depth, table, price. We've also got 3 points at the end, X, Y and Z. What we want to do first of all is rename those so that they become a bit more clear. To do that, let's see the data first. And by doing data and then to diamonds, that makes the diamonds data set into a data frame. If you're familiar with SSRS or SSIS, you'll know that a data set is simply a table of data in rows and columns format. And a data frame is the equivalent in R. We can see some of the data by doing head, and that gives us the top 6 rows in this case. Tail gives us the bottom number of rows. Sometimes it's handy when we're manipulating data just to see a very small part of it. So what we're going to do is we're going to rename columns 8, 9 and 10 so that they become more sensible. So what we see here is names diamonds. That means that we're talking about the row names, and here we're specifically referencing number 8. So all I want to do is rename column number 8, defined by an X here, into being length. Now let's see, if we use the arrow keys, we can start to scroll up. And if we press return again here, what we see at the top here is that the column X no longer exists and it's now been called length. Now that's a really simple thing to do, but trying to rename columns is actually an extremely effective way of engaging business users in their own data. With that in mind, we will rename column 9 to width. We will rename the 10th column to depth. And what I'll do now is I will use the arrow key to scroll up, view the data set again. Now if you're sharp-eyed or have your screen wide open, what you might see is we've got depth as a column here and depth as a column here. Now it's not good practice to have the columns having the same name, particularly in the same data set. So what we will do here is we will have the names of the diamonds of the 5th column and we'll rename that to depth perception. So it's actually very, very flexible. We'll just view to check that's gone true. So now when we view the data set, see we've got price, length, width and depth. So we've renamed all of our columns. Okay, so what we have here is object G1 not found, and what we need to do is what we've tried to do there is visualize some of the data. Now at the moment that doesn't make any sense because we haven't loaded any variables in, and what you need to do with R to make it really powerful is make use of the variables, and that's what we're going to do next. But the first thing we're going to do is, before we do anything, is summarize the data first of all. So what this does is it uses dplyr, and we have this symbol at the bottom, which is piping the data. So basically, piping the data means that the data goes from one step right through to the next. So in this case, the diamonds dataset gets piped and grouped by the cut, and then the data is summarized. And once these things have happened, we get the result. So if we want to see our dataset, we have the example here. And this is the diamonds dataset grouped by the cut, and then we have a summary data item there which shows us the total carat. So let's see. We can filter out the data we've got simply by using this filter statement here, which I'm going to run. So ideal diamonds, diamonds ideal is the name of the dataset, and we're going to filter it so that only diamonds with the ideal cut will make their way through. Then if we do the head of this data, we can see a very small example which shows us that only the ideal diamonds have been cut. We can see from the example above that ideal has a number of different brothers and sisters in the cut column, and we are now using this column filter here. We're going to bring data back to being ideal. So what we want to do is just select some of the columns. We don't need all of them. So what we're going to do here is a small select statement, which you're used to if you're used to SQL Server. Select the diamonds, carat, cut, color, price and clarity. Select these column names from diamond and put them into a dataset called My Perfect Diamonds. Now I want to see the very first part of the dataset. So what we see here is the cut is ideal, premium, or it's good, for example. So why don't we filter that? And what this does is it takes the same dataset as we used previously for My Perfect Diamonds, and then it filtered them. So this time when we try to see the head of My Perfect Diamonds, we get a different result this time. Head My Perfect Diamonds. So instead of head My Perfect Diamonds, bringing us back different types of cuts of diamonds, what you see here is My Perfect Diamonds is now only giving us diamonds that have the ideal cut. And the reason that's happened is because this acts like a filter. Filter diamonds and just gets me the rows where the ideal is the cut in that particular row. So what we can do is we can start to add new columns to our dataset as well. And what we do here is we use the word mutate, which adds new columns or new variables to the dataset. So I'm just going to highlight it so you can see that row, and then I'm going to press run. So this changes the My Perfect Diamonds data frame again. Let's see how that looks. So what we see here is now we have an extra column. We have the price per carat. And all that's happens there is we take price per carat, we take the price and divide it by the number of carat, and that gives us this total down here. And when we take a head of the data, you see that we just get the first 6 rows again. This time we want to sort the data so that it comes back at us already sorted. People tend to like data that's been sorted. It's easier to navigate your way around. So I'm just going to run that just now. And let's see how our My Perfect data set looks at the moment. Let's get the mean of one of the columns. The mean, of course, being the average. So when we do that, that gives us the mean price. So what we can do next is take the dplyr module to summarize the data. And what this RM means is simply that R will ignore the nulls. So all I want to do is run this line here. So the average price is coming up as 1,810. So what's the median of a column? The median of the price column is 2,401. We can see that the median for My Perfect Diamonds for the price is 1,810. So let's see what the minimum is for that data set. The minimum is 326 and the maximum is coming up as 326 as well. Perhaps if we change that, we could see what the max actually is. So we can see the max and the min are quite different. So let's get the standard deviation of a column as well. So that gives us a number for the standard deviations. We could go off and do further analysis there. If we want to just print the data, what we have here is it's given us a printout of the data that it knows about. So here we have the summary here of My Perfect Diamonds, and I'm just going to run that so you can see it. And what this gives you is some of the descriptive statistics we already talked about. It gives us the min, the quartiles, median, the mean and the max. So this time, now when we look at the diamonds data set, and that outputs the data. And what that's going to do is it's going to give us the data where the colour is over a certain value. The data columns, if we could see them right at the top, it's quite hard to see the data set when it's like that. So that's why we start to do head. Then that allows us to see a little bit of it. So what we can start to do is have some fun with the data visualization as well. So this is G1. And what this does is it uses the ggplot package, and it's using the dataset diamonds which comes with R. And then it's going to start using geometric points in order to lay down the graph. If you bear with me, I will run the rest of these variables. Run those little commands there, off they go, and the variables are G2, G3 and G4. So those commands are run. So basically what they're doing is using the X value as a caret, the Y as a price, and the colour is also the price. And there we have our final statement. So then, now our visualizations are in place. Let's put them all together. So we're going to have in a grid all of the files and plots appearing at the right hand side. Oops. Don't know what happened there. Didn't like me very much, did it? So I'm going to see if we can run that again. So what that tells us, we have to go back and start to run everything again. We need to load the libraries again, for example. Now just for the purposes of the demonstration, I'm going to run everything again. I'm going to highlight the lines I want, click on run. It's going to restart R, so we'll just say no. The packages are being loaded, and what you see is we'll start to see some results appearing. Now this is moving as well because that's the history. And here it's running some of my earlier commands in order to visualize the data. So you can script R fairly well. So now when we start to run that again, let's just check. Okay, so object G1 is not found. So what we need to do there is we will need to run these commands here, and they set G1, G2, G3 and G4. G is just simply short for graph. That's all the variable is. So run those 4 statements. Now we'll run that one, and when I do that, what that does is it takes the variable name gradient2 and arranges the grids G1, G2, 3G and G4 into a grid in the plots, and we should see that happening. Okay. So this uses dplyr to summarize the data. We could take away the nulls if we wanted, so to do that we could just run the commands. And the bit that says, that tells R to ignore the nulls of that piece there where it says NA, then a dot, then RM. And the advantage of using this sort of chart is it's very, very quick to do in R, but it would take time to do it in Excel. So it's worth even having a look at R for its visualization capabilities. So we'll get the median of these two types. So we can see down the bottom here that the median of diamond's price is 2,401, and the median of my perfect diamonds is actually a bit less, 1,810. So what we can do now is print out the data, and that's quite hard to read. What we actually want is perhaps a summary first of all. And the summary gives us some descriptive statistics about the data itself. Before we do anything else, I'm going to save that. Now what we have here is we've taken the variable name diamonds, and we're only taking a certain number of diamonds that colours are less than J. So let's read out the diamonds dataset in order to see if that's true. And from the small sample that we've got here, we can see that there's no colours there which are exceeding the letter J. In fact, they are less than the letter J and not equal to it. So that's why we start to see letters coming up to the letter I, but we don't see any J at all. We don't see any J. So let's look at our dataset for diamonds. So we've done some analysis on our data. We have done some summarizing, so we do summary. Then this gives us the summary of the descriptive statistics that we're looking for. This is really useful, so we can try and work out where the minimum is, where the maximum is, and that tells you straight away if there are any outliers. If there are outliers, that might indicate messy data. Alternatively, if there are outliers, it may indicate that a trend is starting. And very often we can see a trend starting as a series of outliers which become more prevalent, and that's really what we're looking for. So what I want to do is save the history, and off that goes. So thank you very much to you for listening to my session, and I hope you will join in on the third session. I will go into more detail in statistics, and thank you very much.